And let me do this integral by using Gauss integral. And okay, first, this is x squared, so the function is an even function. So it can be written as a 2 times this, right? So this e to the negative x squared and the cosine 2x squared. Then I'm using complex number for the real part. That is the real part of e to the x squared and e to the 2x squared dx. Yeah, very good. Now then I can combine them, right? Combine these two, become e to the negative x squared plus 2I. Now for Gauss integral, I must combine them as something square. So this is equal to 2 real parts, which is possible, something negative something square. That is Gauss integral requires, right? So this one is equal to square root 1 minus 2I and x. Yeah, that is this, correct? Then my dx has to be changed into this square root 1 minus 2I x. To maintain equal sign, I must divide by this. So then it's equal. So this becomes this is taking out 2, the real part of 1 over 1 minus 2I. And this is a Gauss integral, right? This is equal to square root pi over 2, because from 0. So the integration, the integral has been finished. Just a matter of convert this one into the real part, and it's done. So this one is equal to root part times the real 1 over. Okay, good. So that is the result. We have to convert this one to the real part. Okay, let me do step by step. Okay, first, I discuss this 1 minus 2I as a complex number a plus bi. A, b are real numbers. Then both sides is square. So 1 minus 2I is equal to a squared minus b squared plus 2abi. And compare both sides, I'll get a square minus b square equal to 1, right? That's the real part. And ab equal to negative 1. ab equal to negative 1. So from which that I know that b is equal to negative 1 over a. Okay, these are just obvious calculations. And then put this one here, and a squared minus 1 over a squared equal to 1. So we have a fourth minus a squared plus 1 equals to 0. Minus 1, sorry, minus 1. So a squared equal to a quadratic formula, 2, 1 plus 1 plus 4. Since a squared is a positive number, therefore we're not taking the negative, and now a is a real number. So forget negative here. So this one is equal to 2, 1 plus root 5. So which means that A is equal to this, A plus root 4, 2, right? And the B is in reciprocal negative. B is equal to negative 2 over 1 plus root 4. Good. Now, so we find the square root of this one. There's 1 over this, 1 over minus y is equal to 1 over a plus bi. So we multiply times the conjugate. This one is equal to a minus bi. So this is a square. Yeah, times this conjugate minus this and plus. All right, good. So the real part of this, therefore the real part of this is equal to a over this. It's equal to a over that. So is equal to, continue from there, this is equal to square root 1 plus root 5 over 2. And the a square is this. A square is 1 plus root 5. This is square, right? Over 2 plus b square. B square is this. 2, 1 plus. So this one is equal to 1 plus root 5. This one, this time this one has it, well, it's equal to 2, 1 over root 5. This one times this one, huh? This one times this one is, this is squared, so this is equal to 1 plus 5 plus 2 root 5 minus 4. Well, so this one equal to, well, tedious calculation. This is 10. No, plus 10. 5 to 10. 10. So it's equal to 5 plus root 5 over 1 plus root 5. Right? Cancel 2. 2 is cancelled out. So this one equal to take root 5 out. This is equal to root 5 plus 1, 1 plus root 5. So it's been cancelled out. So this one equal to 1 plus root 5 over 2. This is root 5. So finally, this is equal to root 1 plus root 5, 10. Yeah, that is this. So my integral I is equal to pi times this. 1 plus root 5 over 10. Yeah, so we can write it together is equal to 10, 1 plus root 5 pi. Wow, that is the result of the integral.